Section 3.8 is solving equations and formulas. So let's see, we're going to start by solving some equations for a specific variable. So if I give you this equation, 3x minus 4y equals 7, and I want you to solve it for y, that means I want to isolate y. So in order to get y by itself, the first thing I need to do is move any terms that do not have y in it to the other side. So the way to move the 3x to the other side would be to subtract 3x from both sides. So negative 4y equals, and these are not like terms, so I have to just subtract them, 7 minus 3x. And then to isolate y further, I've got to divide by negative 4. So y equals 7 minus 3x divided by negative 4. Let's try another one that's got a little bit more going on. If I want to solve this equation for m, in other words, I want to isolate the m. Well, my problem is I have m's on both sides. So the first thing I want to do is put both of the m's together. So I'm going to bring them to the left. So I'm going to subtract pm. So let's see, that's 2m minus pm minus x equals negative 5. Now I'm going to move the x to the other side because I don't want it with the m's. Remember, I'm trying to isolate the m. So now I have a problem because I'd like to divide by 2, but I still need to get these m's together. So I'm going to use our distributive property, and I'm going to say 2 minus p times m equals negative 5 plus x. Now if I divide everything by 2 minus p, I will get m equals negative 5 plus x. I can put the parentheses there, but I really don't need it because the fraction bar acts as a parentheses, and there's my isolating the m. So again, this one's a little bit more complicated because we've got to combine two terms that both have m in them, and we do that using the distributive property. Look through those again and then go on with the video. So sometimes we're going to do formulas. C equals 2 pi r. We all know this as the circumference formula. And this is an equation for circumference in terms of the radius. In other words, we have a formula for our circumference in terms of a variable for the radius. 2 pi is not a variable, that's a constant. So we don't need to put that in our description. We want to now write an equation for radius in terms of circumference. In other words, I want to get r equals something about circumference. Radius in terms of. This in terms of is like saying the circumference equals a formula with radius in it. This is the radius equals a formula with circumference in it. So in other words, this is the same as saying solve for r. So if I want to take this equation and solve for r, I'm going to start with what I had. I want to isolate the r. Well, the only thing in front of the r is a constant, so I can divide by 2 pi. And I will get circumference divided by 2 pi equals r. Or to fit this model a little better, I can say r is in terms of a circumference. So this terminology, I'm really going to stress this for you. So if I have an equation in terms of one variable, y equals 2x plus 1, this is the same as saying y is a function of x. Y is in terms of x, or y depends on x. All of these mean the same thing. Y depends upon the x that I plug in. I plug in an x to get y. Y is a function of x. Y is in terms of x. All of these are really important terminology, and I'm going to use them interchangeably. So if I give you an equation like 3x plus 2y equals 1, and I ask you to write y as a function of x, that simply means solve for y. Put y on one side of the equation and everything else on the other. So in this case, I would subtract the 3x, and then I would divide by 2. So now I have y as a function of x. Now, I know you're used to seeing this in the slope-intercept form, and we can do that by breaking this into two pieces. And we can say y equals negative 3/2 x plus 1/2. But the important thing that we're dealing with, and if you stop here, that's fine, is to get y isolated, solve for y. In other words, write y as a function of x, write y in terms of x, or make y dependent on x. All right, let's do one more with a little bit more complicated formula. Dimensional analysis. This is the process of using units for evaluation. So we're going to look at the units as we do this. Here's a formula that we give you, and this formula represents the distance s, so s is distance, that a free falling object will fall near a planet or the moon in a given time t. So t is time, s is distance. In the formula, a represents the acceleration. So this is an equation for distance, s, written in terms of acceleration and time. Or distance is a function of acceleration and time. Or distance depends on acceleration and time. Now, we're told that acceleration is meters per second squared. So if I take this formula and I put the units in place of acceleration, so distance is in meters, so meters, some number of meters, equals 1/2 of some value of meters per second squared times some value of t that is measured in seconds. And since t is squared, that's going to be seconds squared. Whoops, not the t squared. Okay? So what we end up with is meters equals meters per second squared times seconds squared if I just look at the units. And you can see that that's equal units. So sometimes looking at the units helps us decide what to do. All right, let's look at this a little further. A free-falling object near the moon drops 20.5 meters. So they've given me the distance. Distance equals 20.5 meters in 5 seconds. So they've given me the time. T equals 5 seconds. What is the value for acceleration? Well, I'm going to take our original formula and I'm going to solve it for acceleration. In other words, I'm going to write an acceleration equation. I'm going to write an equation for acceleration in terms of distance and time. So I want to isolate the acceleration. I'm going to multiply both sides by 2 to get the 1/2 out of the way. I still want to solve for acceleration, so I'm going to divide by t squared. So acceleration equals 2 times the distance over t squared. Do my units still work? Acceleration is meters per second squared. Over here, distance is meters. Time squared is seconds squared. So my units still work, so this looks like a good formula. So let's use it. A equals 2 times my distance over my time squared. So that becomes 41 over 25 using my calculator, 1.64, and what's my units? Meters per second squared. Okay, so we're going to do some more of these. Keep in mind that terminology, become familiar with it. y in terms of x, y is a function of x, y depends on x, all just mean solve for y. All right, that's it.